Hello everyone. In this video we will learn about heat capacity, specific heat capacity and specific latent heat. So these three topics, they are different from each other, and how different they are from each other we are going to discuss in this video. So heat capacity. So this is a general observation in our day-to-day life that if you are heating a cup of water and if you are heating a bucket of water, then you can easily guess which one will take longer time and which one will take less time. So which one will take longer time? Provided the same quantity of heat is supplied per second to both the containers. So if you are supplying same quantity of heat, what do I mean by that is, let's say you are using same type of burner and same type of fuel. So which one will take longer time out of these two and which one will take less time? So you can say this one will take longer time and this one will become warm, or this one will start boiling very quickly in less time. So one thing you can very easily guess, that when the quantity is less, then the heat required to increase the temperature is also less, and when the quantity is more, for example in this case, then the heat required is also more. And that is what is thermal capacity. More the quantity, the more will be the heat absorbed by the material to raise its temperature. So how do you define thermal capacity? So thermal capacity is defined as the heat required to raise the temperature of substance by 1 degree Celsius. So whatever quantity of heat is transferred to raise the temperature by 1 degree Celsius, that is called as its thermal capacity. So here you can write delta Q is directly proportional to delta T depending on the quantity of matter. So delta Q is directly proportional to delta T, or we can write here delta Q is equal to C into delta T. Delta T is the change in temperature, and delta Q is the heat transferred, and C is called as heat capacity. So if I want to write this, I can write this as C is equal to delta Q by delta T, and this is what the heat capacity formula. So if you want to calculate the heat capacity of a substance, then you should know the heat given to the system or the substance and the change in the temperature of substance. Now sometimes, or just to trick you in the exam, this heat may not be written as heat, it may be written as energy. So energy given to the system divided by the change in temperature delta T is also heat capacity. Now, sometimes the energy may not be given to you, and indirectly what is given to you? The power and the time for which heat is transferred. So to find the thermal capacity, you can write C is equal to, because you know energy is equal to power into time. Energy is equal to power into time. So thermal, or I should say heat capacity, delta Q by delta T, I can write it as P into T by delta T. So if you want to calculate the heat capacity of substance, you can use power of the heater or the power of the thing which is heating the substance into the time for which it is heated and the change in temperature. So by mistake here I have written small t, and small t represents change in time, which is wrong here. We are checking the change in temperature, so it should be capital T. So delta capital T. So this is heat capacity, and just once again, heat required to raise the temperature of substance by 1 degree Celsius. Now the next thing is, what is unit of heat capacity? So unit of heat capacity, some of you may have already guessed, this delta Q, energy, and the unit of energy is joule, and the unit of temperature is Kelvin, or you can use degree Celsius also, depends what is given in the question. So joule per Kelvin, I'm writing here joule per Kelvin. Sometimes it may be written as, I will write here joule divided by degree Celsius, or joule degree Celsius power minus 1. Right? Now the next topic is specific heat capacity. So see how I'm modifying this topic, specific heat capacity. Just I added specific. Very much like this heading, you can modify the heat capacity to specific heat capacity. Okay, so this is a trick which you can use. Now, what is specific heat capacity? The problem with this method, when the substance is less heat, when the substance is more heat is required to raise the temperature, is that you cannot do the comparison between the heat absorbed by two different substances. Or let me make it clear. So if you want to do the comparison of the substance and you want to know which one is better absorber of heat, then this is quite tricky. You won't be able to know, because comparison can be done between two equivalent things. Those are having the same characteristics, right? So now, if you want to do the comparison, let's say the heat absorbed by 1 kg of water and heat absorbed by 1 kg of mustard oil, right? So now this would be a quite fair comparison, because they both are liquids and we are just taking them as a matter. They both are the matter, and another thing is they both are having the same mass. So this comparison would be quite fair. But if I take 100 kg of water and 1 kg of mustard oil, and if I'm trying to compare which one is better absorber of heat, then that would be not a fair comparison. And specific heat capacity solves that problem. So specific heat capacity says, okay, if you want to compare the two substances and you want to compare the heat absorbed by two substances, then take their equal mass. And now taking the equal mass may not be convenient for many, because they may get confused. Okay, how much quantity I should take for this and how much quantity I should take for this. So scientists, what they did is, they said just take 1 kg of substance or 1 gram of substance or unit mass of substance. So here let me rub the board, then we will discuss further. So heat capacity and specific heat capacity, and I'm modifying this definition. Heat required to raise the temperature of now here, instead of just substance where mass was not mentioned, now here we will mention about the mass. So heat required to raise the temperature of 1 kg of substance or the matter, 1 kg of matter by 1 degree Celsius. This is called specific heat capacity, SHC, specific heat capacity. I have written in short to save the time. You don't write this in exam. So now here delta Q is written as delta Q is proportional to delta T. So here delta Q is equal to C delta T, and finally we got C is equal to delta Q by delta T. Here no mention of mass in this formula, but now we want to mention. So what you can see here, guys, heat required to raise the temperature of 1 kg of substance or unit mass of substance. So what we can do is, we can divide the formula of heat capacity by mass. So heat capacity divided by mass is called as specific heat capacity, S. I hope it's visible. It's not going out of the screen. So specific heat capacity, S, is equal to heat capacity divided by mass. So what is heat capacity? You know, delta Q by delta T divided by mass. So now if you want to write this again, you will get S is equal to delta Q by M into delta T. Now you already know what is delta Q, delta T, and M is here mass. Delta Q, change in temperature, and this is heat transfer to the system. Now most of the time you may be seeing this formula something like this: delta Q, which is heat transfer to the system, will depend on the mass of the system and the change in temperature of the system. And one more thing, what is the capacity of that substance to absorb the heat? So that capacity we can measure by specific heat capacity, and I can write here S because I don't have space here. So delta Q is equal to M delta T into S, in books most of the time it's written as delta Q is equal to ms delta T. Now there is one more important thing, which is unit. So unit of heat capacity, joule per Kelvin. So what should be the unit of specific heat capacity? Specific heat capacity. So unit of specific heat capacity, guys, you may have already guessed, joule, because unit of energy, joule, and unit of mass, I'm taking here kg. Sometimes this mass may be given in gram also, do not get confused. And delta T, Kelvin or degree Celsius. So the unit of specific heat capacity is joule per kg per Kelvin. It's written as joule kg power minus 1 Kelvin power minus 1, or joule kg power minus 1 degree Celsius power minus 1. In next video, we are going to solve some questions related to specific heat capacity. Till then, just keep revising and try to find some questions from textbook and solve it on your own so that you have good understanding. Even if you are confused, keep practicing, because confusion leads to clarity, provided you continue practicing.